Good evening, everyone. And welcome to this presentation. I would like to thank Percona for having me as a guest. I like to think from time to time that I know something about performance. Not because I did something smart, but because I use it. So, who's this guy? My name is Giuseppe Maxia, also known as the Data Charmer. I'm the community team lead of MySQL. I like to hack things, and I like to use things in a way that the developers don't suspect. So this is why I have a reputation for breaking things, and they call it QA. It depends on how angry they are with me. So you know, MySQL was GA in November, and for that reason they made a T-shirt. The T-shirt was made in a limited edition. Only the names that are on the back of the T-shirt receive the T-shirt itself. So if you see somebody with this T-shirt, it means that we can answer hard questions about MySQL 5.1. Okay, we have only 20 minutes. Let's try to use it. What is your need? Of course you want to be performant. What is your problem? Too much data, not enough memory. You have historical data, your data is growing, you have to rotate data, and the normal database cannot help you that much. So your disk is filling up, you have indexes that are almost the size of the RAM, or even worse, the indexes are bigger than the RAM. So what can you do in this case? You can use partitions. So let's see what partitions are first. Partitions is a logical splitting of tables, as in it is transparent to user, so you don't need to do strange things like you used to do with merged tables. Who has ever used merged tables? Okay, so you know the pain. So merged tables were kind of nice, a nice hack, but you have to use separate tables and you have risk of duplicates. Most of the maintenance of the tables were done in the application, and the database cannot help you more than cannot help you at all, actually. With partitioning, you have only one table, so it looks like a table. It is one table. You can use indexes, you can use primary keys, you can insert in one table, and constraints are enforced. So what is this logical split? Let's see an example. You take a map. I know that it doesn't look like a map, but I'm not a designer. So you cut the map into pieces, I mean physically, with scissors or just rip it apart. And then you have several pieces. So you take the piece of the map, go walk around, it worked perfectly. Then, if you want your map back, you have to glue it, which is a problem. So this is physical partition. Instead, logical partition, take the same map, you fold it, and when you are done with the map, you just unfold it back, and the map is there. So this is logical partition. And MySQL partition is logical partition, meaning that we are not breaking anything, I hope, and you can use it. You can also do the physical partition if you want, so you can tell the engine to send several pieces of the database or the table in different paths, but it's not mandatory. Why do you want to use partitioning? There are a few reasons. You want to make insert faster. You want to make range select faster. Now this is the best thing that you can do with partition. Remember that. Range selects, if you have a problem with range selects, partitions are the solution for you. Or one thing that many people use partition for, if you have the need of removing chunks of data instantly. I'm going to show you an example. So how does it work? Now, in a tutorial, I will go through it and explain the syntax step by step. But here, I have to tell you, really, look at the manual, because the syntax for partitioning is long. I'm going to just give you an example because time runs. So you can create table, and until the end of the parenthesis is the same, so engine equals InnoDB, and then you put partition by range ID, the name of the column that you want to partition by, and you define your partitions. You can partition by range, by list, by hash, or by key. And we can go through this in some other moment. What I want to show you is how to do some performance with partitions. Limitations of partitions: you can only partition by integer columns, so natively you cannot partition by dates, but there is a way of doing that. You can use functions or expressions to get an integer out of your column. Another limitation is that your partitioning column must be part of a primary key if you have a primary key. If you want to partition by date, which is a common need if you have historical data, you use one of two well-performing functions. There are two functions that are defined in the partition engine to work very well with dates. One is year and one is 2 days. So if you want to partition by year, it's very simple. You just define partition by range year, and then you define the values that you want for each partition. If you want to define by month or by any other date interval, use 2 days. Are you with me so far? Good. So when to use partitions? First, if you have large tables. If you have small tables, don't bother. You don't need partitions. Another thing that you have to remember, if you want to use partition, you should, or you must, depends on how strong you feel about that, you should always query by the partition column. So if you don't use that partition column in your queries, you're going to have either a full table scan or you are using the index. And if your indexes are larger than the available RAM, partition is for you. So, how does it work? I used some components to do some testing. I use MySQL Sandbox, and if you are interested, there is a BOF about that at 8:30. I use a test database that is published in Launchpad that has 4 million records, and I use some manual ability. Employee database, I have two large tables, titles and salaries, that I partitioned. The other I didn't bother. How many partitions we have? 19. How do I know? I go to the information schema. There is a partitions table that gives me some information about the partition. Now, we have 2,800,000 records. What do we do? With a non-partition table, we ask for a range set of data, and I get an answer in 152 seconds. I do the same query in a partition table, and I get the answer in 0.41 seconds. Now, this is partition P15. How do I know this? Because I'm looking for data in 1998, and if you go back to the information schema partition, you see P15 is year from date, and this value is less than 1999. So this is the data for 1998. So partition B15 contains data for 1998, and using partitions I have a query that is 3 times faster. The same happens if I use another year, 154 non-partition, 017 partition. Now, here's the real benefit depending on your needs. If you want to delete 1 year from the table, without partitions, it takes 19 seconds. Using partitions, you can just drop the partition and it takes 35 seconds. This is an enormous advantage if you are doing these kind of things very often. One thing that you can use when you don't want to use partitions directly in production, you can use replication. So you have your master that is normal, and you have some partitions in your slaves depending on what you need to do. For example, your master has InnoDB non-partitioned, then you have one slave that is exactly the same thing and you use it for concurrent reads or use it as a replacement master. Then you have another slave with InnoDB partition by range. What do you use it for? You use it when you have a batch processing that you have to do concurrently, meaning that you can send 10 queries, each query in a different partition, and they will do what you need. This is much better than doing 10 queries on a non-partition table because partitions are more efficient than indexes. Or you can have a MyISAM for large statistical queries. Depending on what you need, you can be creative. You can have InnoDB partition on the master if you need to speed up the inserts, and replicate to a MyISAM partition. So there is no limit to your imagination. Pitfalls, something that you have to remember when using partition. Now, the most important thing, especially when you are partitioning by date, you partition by function, for instance, by year, name of the column, but you have to search by column, because if you search by function, you don't get the result you want. I mean, you get the records you want, but you get it slowly. Example, you have partition by range, year from date, and you select using year from date in the where clause. Wrong. Why? Because the partition pruning doesn't kick in. So in this case, it takes 225 seconds, meaning that you have a full table scan. Instead, if you search by column using between, then the partition pruning kicks in and you have your result in 0.45 seconds. How do I know? There is an addition to explain. So in MySQL 5.1, you can have explain partitions to the query that you have already that you have sent. The first one, the wrong one, it gives you a long list of partitions, meaning that you have a full table scan. Instead, for the query that is done correctly using the column, it tells you that it's using 2 partitions only, so the partition pruning is working. Benchmarks, let me show you some numbers. So, using my laptop and the database that I showed you before, I have an occupation in storage of 2021 megabyte for InnoDB, 180 for MyISAM, 74 for archive. If I partition, InnoDB is a little bit larger. InnoDB partition with 5 per table is extremely larger. I don't know the reason for that, but this is the result that I got. And MyISAM partition is almost the same size. Take a look at archive. Archive is very much smaller than MyISAM and InnoDB. Why do I mention archive? Because archive is good enough depending on your needs. So this is a benchmark result in my laptop, which is not very much useful because, you know, in a laptop you don't have, you cannot compare to a server. But anyway, you can see that the results are quite good for all engines. InnoDB, MyISAM, and Archive compared to non-partition table perform very well. Also, the InnoDB partition file per table is acceptable. But if you use a huge server where we have a database of 330 gigabytes instead of 200 megabytes, the difference is a little bit larger. So we have InnoDB with primary key and MyISAM with primary key that get 330 gigabyte and 140 gigabyte. When we partition without primary key, we get 37 gigabyte and 107 gigabyte. And archive is only 13 gigabyte. Now, why without primary key? Because in this particular case, the primary key is so large that doesn't fit in memory. So in this server, I have 32 gigabytes of RAM, and the primary key was 40 gigabytes. So let's see the comparison. If I query InnoDB, the query takes 4 minutes and 30 seconds to get 6 months range of account of 6 month range. All these queries were run when the database started. So I stopped the server, I cleaned the memory, and I restarted the server with only one engine active at any given time. MyISAM is faster because the primary key for MyISAM is smaller and it fits in memory. Archive takes 22 minutes because it's a full table scan, so we are talking about 700 million records. InnoDB partition by month is 13 seconds. MyISAM partition by years is 6 seconds. MyISAM partition by month is 4 seconds. Why I don't have InnoDB partition by month? Because it took so long that I couldn't finish the loading. But anyway, InnoDB took 20 hours to load. MyISAM took only 3 hours. Archive partition by year takes 16 seconds, and archive partition by month is 9 seconds. So if you have large amounts of data, archive plus partitions could be a good choice. Usually, if you have a data warehouse of this size or something larger, I mean something that doesn't force you to use InfoBright or Kickfire, MyISAM is a better choice than InnoDB, also because your data is supposed to be already filtered when you are at this stage. Tools, and I'm almost done. So the information schema partitions table is your friend if you want to know the information about partition, the metadata. You can get that from the information schema. The partition helper is a tool that you find in MySQL Forge, or if you look at my blog, you will find not only the link to the partition helper, but also the description. So it's a Perl script that creates partitions. If you have to create 300 partitions, you don't want to do that manually, you want some help. And the partition helper is something that does that for you. Tips: if you have large tables like I was saying, do not use indexes, use partitions. And most important, before using partitions in production, benchmark. If you want more details, look at my blog. For large historical tables, archive is very good. Is not as good as fast as MyISAM, but is good enough, considering that you have 1/10 of storage only. So this is the end of my presentation. Questions? I have 1 minute for questions. Yes.
The InnoDB file for table with partitions, is that repeatable, the fact that it's much, much slower than?
Yes.
So it's...
Not slower, larger.
Oh, okay.
It's not slower, it's larger. Yes.
If you alter the table, partition table, will it be locked for all of the data? For example, if I want to add a column or something like that, you were comparing with the situation when I have different tables. And in this case, if all of these tables have a lot of inserts, I can just run outer table for all of them, and nothing will be locked. I mean, it will not be locked immediately everywhere. But what happens in partition table?
It will be locked. Yes. I mean, you're not supposed to add columns in production. That's what I tell my students.
I
but
disagree.
Okay. What happens when you, if you need to add a new partition? Does it have to? Is it going to be a long time, or how do you try and add a new year partition? Or
if you have to add a new partition, you can add the partition at the top. So it doesn't take long because it will only add a new partition if you have for instance, the highest value is 2000. We want to add 2001 is immediate. If you want to take 2000 and split it, then it will take as much time as to process as it takes to process all the records for that partition only.
Can you partition on top of federated tables?
No.
Why are inserts slower?
Insert slower. Insert could be slower, depends, but it could be much faster than inserting on a big table. Now, it depends on how you insert it. So if you are inserting random records, it will be slower because you have to change partition for each record. If you insert in sequence, it will be much faster. And I think I ran out of time. Yes. Okay, I will be available in the corridor if you have more questions. Thank you.